Measurement is the common practice of everyday life. This routine work starts from morning till late hours in the night. Every morning, a milkman comes and gives a measured volume of milk to the household with the help of his measuring cylinder graduated in halves of d- deciliter. Uh, if one goes to a shop to purchase sugar, the shopkeeper will weigh the required amount of sugar by his common balance and will hand over it to the purchaser. To purchase clothes, one goes to the shop and the shopkeeper will measure the required length of the cloth by his meter scale graduated in centimeters. From these examples, it is clear that to measure volume, mass, and length, we use measuring cylinder, common balance, and the meter scale respectively as the measuring devices or instruments. Similarly, if a college student goes to his laboratory to perform experiments, he may be asked by the laboratory in charge to find the thickness of a thin glass slab, the radius of a curvature of a lens, or density of a metal block, so on and so forth. The student will use the measure devices generally called apparatus suiting his experiments. Thus, the physical quantities like length, mass, volume, time, current, voltage, and pressure etc. are measured by the instrument measuring devices of the relevant type. The accuracy of measurement depends on the quality of the instrument used. For example, to measure the length of the rod in the laboratory, we use the scale graduated in centimeter. The least measurement that is scale can make correctly is 1 centimeter. This least measurement is called the least amount of the scale. In order to measure the small lengths like the thickness of a thin slab, the radius of thin wires used in laboratories etc., we use vernier calipers or micrometer screw gauge. They can measure correctly up to 0.1 mm or 0.1 centimeter or 0.01 mm or 0.001 centimeter respectively. They are called the least counts of the respective measurement instruments. Almighty Allah has created everything in this world with the best estimation, from a huge glacial body to a subparticle of an atom. Everyone is working in its domain under certain principle which has been assigned for it by Allah. Man has to discover these principles. Physics is largely involved in discovering the law of nature through precise measurement of various physical quantities. Scientists have divided all physical quantities into two groups: a fundamental quantities, B. Derived quantities in physical length, mass, and time are supposed to be the main fundamental quantities, since scientists all over the world have recognized that all physical quantities in mechanics can be expressed in terms of these fundamental quantities. To measure a physical quantity, we need a certain unit, so the unit to express fundamental quantities are known as fundamental units, and the units used to express other physical quantities that are derived from fundamental units are called derived units. But what is meant by the word unit? A unit is fixed by definition, and a standard is an embodiment of a unit under certain physical conditions. Measurement means the comparison of a known quantity with a standard to see how many times it is big or small as compared to the standard. A set of fundamental and derived unit is known as system of units. These are three systems of units being used in scientific work. In the CGS system, centimeter, gram, and second are the fundamental units for length, mass, and time, respectively. International System of Unit is abbreviated as SI from the French Lie System International d unities. In this system, seven quantities have been accepted as fundamental quantities. They are length, mass, time, electrical current, amount of substances, thermodynamic temperature, and luminous intensity. And units of these quantities are meter for length, kilogram for mass, second for time, ampere for electric current, mole for amount of substances, Kelvin for thermodynamic temperature, and candela for luminous intensity. As a system of unit is convenient for scientific work and provides a simple method for calculation. British engineering system is an old system. In this system, fundamental quantities are length, force, and time. Note that in this system, mass is a derived quantity and its unit is derived from the force unit, that is pound, and is called slug. The basic unit for length, force, and time are foot, pound, and second, and respectively. In the past, spin motion of the earth about its axis and its orbital motion around the sun have been used to define second. In October 1967, the time standard gained redefined in terms of an atomic clock. The atomic clock uses caesium of mass number 133. According to this clock, a second is defined to be exactly equal to the time interval of 9 192 631 770. Vibration of atom of cesium airs will differ by 1 second only. Another clock has been invented which uses hydrogen and known as hydrogen master clock. This clock has achieved a precision of 1 second in 30 lakhs years. It means that if two hydrogen master clocks were started simultaneously and they were allowed to run over a period of 30 lakhs years, then the expected difference between their time would only 1 second. The advantage of this method is that the cesium clock or hydrogen master clock can be constructed in a convenient laboratory and the standard of time second can be checked. It is to be noted that no matter how the standard is defined, the method always involves some sort of periodic motion. 1 kilogram is the mass of a platinum iridium alloy cylinder which is kept at the International Bureau of Weights and Measures in Sevres, near Paris. Replica of this internationally agreed standard of mass have been sent to several countries.